Welcome back. So today we're going to focus on two new learning targets. We're going to talk about how to find the zeros and their multiplicity of a factored polynomial and to write a polynomial function from its zeros. So far for polynomials, we've looked at standard form, naming by degree and number of terms, and behavior and mins and maxes. Today we're going to begin looking at the zeros of a polynomial. Okay, so when we're talking about zeros, it can be called a zero, a solution, a root, anything like that. So what we're talking about though is if you have a factor of x minus a. If it can factor and that is one of the factors, that means a is a zero, is a solution, or is a root of that polynomial. Okay? So let's look at what this means. So let's recall, if you're given this and you're asked to find the zeros, basically that is asking for the zero product property. Set it equal to 0, and now you have each piece. So what would make this piece 0? Well, an x of -2. What would make that 0? Well, x being 1 would make that 0. What would make that 0? Well, x equaling 3. So this one would have 3 solutions because its factored form has 3 pieces to it. Okay? Now, if you ever have an x sitting out front like that, where it's not part of a parenthesis, it's just sitting there, well, that means if x equals 0, the whole thing would be 0. What would make this 0? Well, an x of -4. That one right there, remember, that one is a slightly more complicated one, where I would still like you to show your work of setting it equal to 0. So add 3, divide by 2, and that is how you can find that 0. Okay, so don't be afraid to still show a little work here. All right, I just want to make sure you're not making just silly, careless mistakes. Now, what do I mean when I use the term multiplicity? When a linear factor appears more than one time in a polynomial, it makes a multiple 0. So in general, a is a 0 of multiplicity n means that that factor of x minus a appears n times, or that is the exponent of that factor. All right, so let's see what I mean by that. So this right here is a 0 of 1. All right, so that 0, the 0 is 1. What's its multiplicity? Well, it has an exponent of 2. So when it has an exponent like that, that gives it a multiplicity. That 0 has a multiplicity. It is being expressed twice in that polynomial. You've seen this before. When the vertex was sitting right on the x-axis, that was having a multiplicity of 2. And what about this one? Well, -5 makes that 0. And it doesn't have an exponent showing. So just like all the time, if there's no exponent being shown, it just means the exponent is 1. So it just has a normal multiplicity of 1, only being expressed once. And then this one right here, well, that has a 0 of -4. Next to -4 would make that 0. And it's going to have a multiplicity of 3. It's being expressed 3 times in that polynomial. All right, let's take a look at this one. Well, remember I said, when x is sitting out front, it's not in a parenthesis. That means that it is actually just an x of 0 that makes that thing 0. And it has a multiplicity of 2. Its exponent is 2. This one is a 0 of -7. -7 would make that thing 0. And again, it doesn't really have a multiplicity showing, so its multiplicity is 1. This one right here is not one that I still do want you showing your work. want you to show yourself adding the 5 over, and then dividing by 2. So it's a 0 of 5 halves with a multiplicity of 5. It's going to be expressed 5 times in that polynomial. So that's how you find all of these zeros, okay, which you did before. So now we're adding the concept of multiplicity. They can be expressed more than once in a solution. Right now, just a little fun fact for you is those multiplicities, they affect the graph, okay? What they do is when you have a multiplicity, so this 0 has a multiplicity of 2, look at how the graph curves right there. Multiplicity of 2 is giving it a curvature like an x squared function, like a quadratic. So that 0 around the 0, the polynomial would take on the features of the graph of that multiplicity. So a multiplicity of 2 is going to take on the form of a quadratic near that 0. Now, that's something that you have to really know per se for the test. It's just something I think is a fun fact to share with you. These multiplicities are affecting the graphs. The other learning target for today is if I give you the solutions, can you go back and can you write out the polynomial in standard form? Okay? So, notice if you have a 0 of 4, it means it has a factor of x minus 4. If you had a 0 of negative 5, it means you started with a factor of x plus 5. So notice that sign change. When you're going from a 0 to reconstruct the factor that made it, you have a sign change. So here, write a quadratic polynomial in standard form that has zeros 3 and negative 1. Well, a factor of x minus 3 is what makes that 0. And x plus 1 gives you that 0 of positive 1. Okay, or sorry, 0 of negative 1 is what I meant. So I can write that out. And now if I want that in standard form, well now I have to FOIL it. X squared plus 1x minus 3x minus 3. So my polynomial in standard form would look like that. And that's going to be my solution. All right, let's try another example. So a cubic polynomial that has those zeros. Well, that's going to be an x plus 2 to create the 0 of negative 2, x minus 2 to create a 0 of 2, and x minus 3 to create a 0 of 3. Now here I want you to be intelligent with your foiling, all right? Because when you FOIL this, I would FOIL these two together first, all right? So these x's will give me x squared. Now notice this, 2x minus x, or 2x minus 2x, gone. You don't even have to worry about that middle piece, okay? So I want you to get used to that, all right? If you have two oppositely signed things, those middles disappear, and you just get a minus 4. Now the downside when you're dealing with cubics is that you're going to have to FOIL this twice. Okay, so now I'm going to have to go through the FOILing process a second time. X cubed minus 3x squared minus 4x plus 12. And that is going to be that polynomial in standard form. All right, so let's do another one. Write a cubic polynomial in standard form. The zeros 1, with multiplicity of 2 and negative 3. So what that means, the 0 of 1 is equal to x minus 1. With the multiplicity of 2 means I have it twice. And then that 0 of negative 3 is going to come from a factor of x plus 3. Alright, so here now I have to FOIL this out again. So, let's start this side. There's no convenient FOILing. I'm really just going to have to go through and do it. X squared negative 1x minus another x, so negative 2x, and a positive 1. So I FOIL out that first one, and now I have to FOIL this again. Now, technically it's not FOILing, because FOILing only works with 2 binomials. But what you can do is just take everything from this first one, multiply to everything in the second one. Let me show you what that looks like. X cubed plus 3x squared minus 2x squared minus 6x plus 1x plus 3. So just take everything from the first one and multiply it to both in the second one. And that's what you can use basically instead of having to FOIL per se. But now this thing has to simplify. So I have x cubed 3x squared minus 2x squared, plus use me with x squared. Negative 6x plus 1x is a negative 5x, and then a plus 3 at the end. So again, basically FOILing twice, but this one is a little bit more complex, a little bit more involved than normal FOILing, but still completely doable. Okay, now let's go back and review all of those things that are part of these. All right, so looking at my polynomial here. So name it by degree. Its degree is 3, so that's going to be a cubic. Name it by number of terms. 1, 2, 3, 4. So that makes it a polynomial of 4 terms. And behavior. Okay, it's odd and positive. That means it's going to look like that. So it has down, up, and behavior. Let's look at relative maxes and mins. All right, so let's whip out our calculator here, and let's graph it. So, sorry, I have to erase that. So we have x cubed, plus x squared plus x squared minus 5x plus 3. So let's look at those relative maxes and mins. See your relative max sitting right there. Let's go calculate it. So max, go to the left, to the right. And it's sitting at negative 1.67, 9.48. 1.67, 9.48 is the max. Now let's look at the min. The min is going to be sitting right there. So let's calculate what it is. Min and to the right. And that min is sitting at 1. And again, whenever you get this gobbledygook nonsense, just consider that to be 0. So the min is sitting at 1, 0. So again, just working on building this all up. Working on describing polynomials in every way possible. So take a moment now that we've gone through these notes, and please write your brief summary for me. Talk about the build of how all of this is coming together, and then come back ready to do your notes or your practice work.